Hey there Excelers, welcome back to our channel. In today's video, we'll be going through all the financial functions in Excel. Basically, we'll see why, how, and when do we use them. So first, what are financial functions? Financial functions in Excel are predefined formulas that perform various financial calculations like knowing about your investments, your interest rates, your payment period, your amount of payment, etc. So, the first function we'll be looking into is the FV function, which stands for the future value of the investment. It basically shows how much will be the future value of your investment that you have invested today. So, here's the basic formula. FV, the name of the function, in brackets, the rate, which is the interest rate, then N per, which is the number of payment periods, and then there's PMT, which is the amount of payment that you have to do, and there's PV, which is the present value of the investment, and then there's type with a close bracket at the end. So I've got you guys a sample data over here to make things simpler. So here we have taken a period of 10 years and the periods per year for payment is 4. That means we'll be paying quarterly. So the annual rate of interest is 10% to just make the value simpler, and the present value of the investment is 1 lakh rupees. And the amount of payment in each period I haven't mentioned. It's just to make you understand it in a better way. So type here basically means when you'll be getting your interest or the benefit from your investment. End is 0, which means you'll get it at the end of the year. And if you're getting it at the beginning of the year, it is 1. So here I'll be getting it at the end of the period. So I've mentioned 0. So at the side, you'll be noticing that there are a few formulas. So it basically tells what is a half yearly or quarter yearly rate of interest. So it's derived from the formula of annual rate of interest, which is divided by the number of payment periods, which means your 10% will be divided by 4, which is 2.5% per period. And the next one is number of times the payment has to be done, which is basically the periods per year into the number of years. So you have to pay 4 times a year for 10 years, which is basically that you have to pay 40 times in 10 years. Now let's start with the formula. So we first start with an is equal to sign, then we type in the function's name, and then we have to add the rate of interest, which is C6 divided by C5 cell. Then there is C5 into C4 after a comma, the number of payment periods per year. Actually, if you don't remember the formula, Excel already provides you the formula below, so which you can refer to. You don't have to just mug up all the formulas. This is one advantage that Excel gives you, and there are many more, trust me. Then again a comma, and you have C8 cell payment amount. And then after another comma, you give the value of C7 cell, which basically tells the present value of your investment. And then you type in the cell C9, and then you close the function with the bracket. And now if we click enter, we get a negative value. Let me explain the reason for you. The thing is, you have to have one positive value in your formula and one negative value, because the present value and the future value of an investment are opposites. Either the present will be low and the future will be high, or the present will be high and the future will be low. So you cannot be determined, but then they both are inversely related. To make the value positive in the formula, we have to add a negative sign after the is equal to sign, and ta-da, you get the positive future value of your investment. Next, we'll go with the PV function, which shows you the present value of your investment function with regards to your expected future value and your annual interest rate. So as the formula goes, it's PV, the name of the function, the interest rate, the payment periods, the amount of payment, and here it's almost same as the previous formula, but then instead of present value, you add the future value of your investment and then type with a closed bracket. Here also we have a sample data where we have a period of 5 years and we'll be paying 2 times a year, which is half yearly, and the annual rate of interest is 10%, and the future value of your investment is expected to be 50,000 rupees. The amount of payment in each period is 0. I haven't mentioned, you can mention that as well, and the type is 0, which means I'll be getting my returns at the end of the year. So, to calculate the present value, you start off with your is equal to sign, PV, the rate, which is basically cell C6 divided by cell C5, then the number of payment periods, which is cell C5 into cell C4, then your payment in cell C8, then your future value, and then cell C9, the type. All of the values separated by a comma and then closed with a closing bracket. Now when you press enter, you again get a negative value. The same concept applies here. So go back and add a negative sign after is equal to sign to get a positive value. And there you go. You found out your present value of your investment using your future value. Next, we'll be looking into the NPV function, which is the net present value of your investment. So, the net present value function calculates the worth of a future investment today by considering a series of positive or negative transactions that you've gained from it with a constant interest rate. It's a financial analysis tool that helps determine if a project or an investment is feasible or not. The formula goes like NPV, which is the name of the function, open brackets, the rate of discount, and the values of returns that you get each consecutive year with a close bracket. We also have a sample data here which says that the initial investment cost is around 80,000 rupees. The return in the first year is 22,000, second year 15,000, third year 7,000, fourth year 12,000. Now you can notice that they all are not pretty constant. They keep fluctuating and the annual discount rate is 10%. So to calculate our NPV, we start off with an is equal to sign. Then you give your cell C9, which consists of your annual discount rate. Then you click on cell C5 and drag it till cell C8, or either enter all the cell names accordingly and then close the brackets and press enter. And now here you've got the amount of actual gain that you've earned from your investment. You can also try this by altering the values like the percentage of annual discount or even the returns that you have earned every year. But now when I go to the initial investment cost and change its value to 1 lakh, there's no change that occurs in the NPV. This is because you've not added your gain to the initial investment, which gives you the net present value of your investment. So to complete this function and fulfill it, we go back to our formula cell and we add cell C4 to get the actual net present value of our investment. So we wrap up here and that's it for today, guys. I hope this was some useful content that would definitely help you. If you liked the video, do like, share and subscribe to our channel, and let's meet in the next video.